Hello everyone, welcome to the course Formal Languages and Automata Theory. This is lecture number 6. In previous lecture we have discussed about finite automata and its types. And in today's lecture we are going to discuss about DFA, formal definition of DFA, and we are going to represent DFAs. Let me share the screen how we are going to represent DFAs here. Yeah. Today's concepts we are going to discuss about deterministic finite automata, formal definition of deterministic finite automata, and representation of DFA. Coming to deterministic finite automata. Here the definition is like this. Deterministic refers to the uniqueness of computation. It is an uniqueness of computation. The finite automata are called deterministic finite automatas. That means the uniqueness of computation which of the systems will be having, those systems are called as deterministic finite automatas. If the machine can able to read an input string only one symbol at a time, it can read only one symbol at a time from a string, then it can be called it as DFA. Now, in DFA, there is only one path for a specific input from current state to the next state. Suppose if we are going to consider Q0 is one state and Q1 is another state. From Q0 to Q1, you will be finding only a single path with a single input, right? Next, DFA does not accept null moves. That means it does not accept any epsilon or any empty string. Epsilon is nothing but empty string. Without any input symbol, it is unable to move from one state to the another state. Next, DFA can contain multiple final states. It can contain multiple final states. Suppose I am going to consider Q0 and Q1. Here you consider Q1 may be one final state and Q2 is also representing final state. Like this way you may have the situation. Q0 on A it may go to final state Q1 and Q0 on B it goes to final state Q2. And the main use of this DFA is going to be used in lexical analysis in compilers. We'll be seeing the applications also later. Then coming to this diagram, here we have represented a DFA. Each state is representing with an input symbol and how the transition is going to be made. Now coming to the formal definition of DFA. A deterministic finite automata can be defined with quintuple. Quintuple is nothing but 5 tuples. Here what are the 5 tuples we are having? Just you observe Q, sigma, delta, Q0 and F. These are the 5 tuples which you are going to have. And we are going to see each and every tuple what it is representing. Capital Q represents set of states. And sigma represents set of input symbols. Then delta represents transition function. Here the transition function we are going to represent with Q into sigma to Q. By taking set of states and set of input symbols, we are going to get transition function. Then Q naught. Q naught is the initial state that will be taken from the set of states. Then F is the set of final states. That means you may have more than one final state also. Then coming to the representation of DFA. Here the DFA can be represented in three ways. One is by using transition diagram. The other one by using individual writing all 5 parameters. That means all these 5 parameters what we have. Then transition table. First we will be seeing about the transition diagram. Transition diagram, here we are going to have the states and transitions. Here we are going to have states. These are the states. And the transitions are nothing but the arrows which you are representing. Right? And how many states are there here? Q0, Q1 and Q2 are the states. States are nothing but when you are going to represent a circle that represents a state. And transitions are nothing but you are going to use arrow that will be moving from one state to the another state. And here you are going to find the states, or you are going to have Q0, Q1 and Q2 are the states. And the input symbols are 0 and 1. Okay, this is the transition diagram. And then coming to the next one, we have individual representation of all 5 parameters. By taking the transition diagram, I will be showing you how we are going to represent all the 5 parameters. We all know that these are the 5 parameters that was present in DFE. Here Q is nothing but set of states. What are the states that was present in your transition diagram? That is Q0, Q1 and Q2. And what are the input symbols? That is 0 and 1. Now you will be knowing clearly or detailedly about the transition function. For each state you will be having an input symbol. Here what are the input symbols we are having? 0 and 1. For each state we need to represent 0 and 1. Then only it becomes a DFA. Now Q is Q0, that is capital Q is Q0, Q1 and Q2, and sigma is 0, 1. Now represent the transition. By using delta and an input state and an input symbol, we are going to get the output. Now delta of Q0 on 0, it is in the same states. That's why we have represented Q0. Next, delta with Q0 on 1, it is moving to Q1 state. That's why we have represented Q1 here. Next, delta on Q1 on 0, it is moving to Q2. Right? Next, delta of Q1 on 1, it is moving to Q0. That's why we have represented Q0 here. Next, coming to Q2 on 0. Q2 on 0, it is moving to Q1, and Q2 on 1, it will be in the same state. Like this way, we need to represent the transition for all states and all input symbols. And what is Q0? Q0 is the initial state. And what is F? F is the final state. Here, the initial state and final state are representing the same. Then coming to the transition table. Okay, this is the third method how we can represent DFS. And this is a transition diagram we have seen previously. From this, how we are going to represent the transition table. Just if you are going to observe states, the column is representing states, and here the row represents input, that is 0 and 1. Now, based on the On this transition diagram, how we are going to fill this transition table? Just you observe. We have seen in the previous diagram, Q naught on 0. Q naught on 0, it is in the same state. That's why we need to represent Q naught. Q naught on 1, it is moving to Q1. Right? That's why we need to represent Q1 here. Next, Q1 on 0, it is going to Q2. Right? Q1 on 1, it will be moving to Q0 state. And Q2 on 0, it is going to Q1, and Q2 on 1, it is in the same state. But when you observe the initial state and final state, both are representing the same. This is not the one. Okay. Like this way, we are going to represent the transition diagram. And by the end of this lecture, the student can able to define what is DFA, and the transitions, diagrams, tables can be represented by make use of DFAs. Thank you.